Hey there guys, it's Mrs. Long and I was coming to you today to talk about multiplication. So you've gotten into the multiplication units and there's a few different things that I want to go over in regards to multiplication to help you to be more successful and understand the content in these lessons. So the first thing, and you guys will hear me say this a lot because it's really the key, you need to memorize your multiplication facts. Okay, I'm going to say that again. You need to memorize your multiplication facts. Why? Well, because starting now through the remainder of the school year, multiplication is going to be a huge part of our curriculum. We're going to be using multiplication basically to do everything else we do in fourth grade math. Okay, so knowing those facts quickly and correctly will help you to be able to be more successful in solving problems. It's just like reading fluency. When you pick up a book and you go to read it, if you can read the words quickly and correctly, you're more likely to understand what you're reading and to be able to comprehend it and to use that information. The same thing is true with math. You have to have what's called math fluency. Math fluency means you're able to solve problems quickly and correctly. So if you're sitting there and you see that you have to multiply 8 times 7, but you don't know what 8 times 7 equals, and you sit there and stare at it, then you might forget the steps to the problem. You might forget what you're doing. You're going to feel frustrated. You're going to start feeling like, I can't do this. Math is too hard. And it's simply because you don't have that fact memorized. So that's going to be the very first key. You have to memorize those multiplication facts. If you don't have your facts memorized yet, I am going to be posting videos in a specific folder in the math videos section for multiplication facts. There's songs, and these songs will help you to remember how to skip count, because if you can skip count by a number, then you can multiply by that number. Let me give you an example with a number you already know how to skip count by, 2s, right? If I see that I have to do 2 times 7 and I don't immediately know what 2 times 7 equals, I can pull up my trusty fingers and skip count by 2 7 times, and then I'll have the answer for 2 times 7. 2, 4, 6, 8, 10, 12, 14. 2 times 7 equals 14. Same thing if I do it by 5s. If I want to know what 5 times 9 equals, 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, 5 times 9 is 45. So 2s and 5s are usually easy for kids to multiply by, and 10s too, because you already know how to skip count by those numbers. But you might not know how to skip count by 3s, 4s, 6, 7, 8s, and 9s. Well, these songs will help you to learn how to do that. And then you can do that just as easily with your 3s or your 7s or your 9s. You can pull out that song and sing it in your head, because it's really easy to memorize songs. We can memorize songs a lot easier than we can just memorize information. So if you memorize that song, then you're able to skip count by those numbers. So check out those videos if you're needing help with memorizing your facts. You also need to have a strategy, okay? Let's say you haven't memorized the song, you haven't memorized your facts. You need to either know how to draw an array or to skip count and use your fingers in your head. Like let's say, I'm gonna give you a quick example. If I wanna know what 7 times 3 equals, I have to count by 7 3 times. Okay, so I could do this. I could go, okay, well, I know 7 times 1 is 7, so I'll just start with 7, and I list it. Okay, 7 times 2. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oop, I did that wrong. 15, 16, 17, 18, 19, 20, 21. All right, there I have it. 7 times 3 equals 21. Now again, not the fastest strategy. That is going to take more time. However, you have to have a tool or a strategy to know how to figure out how to solve the problems. Okay, so that's where we're going to start. You have to either have a strategy to solve your multiplication facts, or even better yet, have those facts memorized. If you don't have your facts memorized, practice them every single day until you do. And even when you do have them memorized, continue to practice them. Maybe not every single day, but at least once a week, to help your brain remember that this is important information. I need to keep this locked in my brain. Okay? So that's the first thing. Now let's talk about estimating. Estimating is a tool that we can use to help us as we're doing math, and it helps us to make sure that we are doing math correctly. Estimating is not a huge part of our curriculum. It is always how different computation skills are introduced. You did estimating with addition and subtraction. You're going to do estimating right at the beginning of multiplication, and then you do estimating right again at the beginning of division. but it's not something that you're going to use a whole lot. However, I do want to give you some tips. So let me say I am multiplying 37 times 17. 37 times 17. Okay, this is 2-digit times 2-digit multiplication. Well, what am I going to do? I'm going to estimate. Estimating is basically rounding. Now here I only have basically one place value I can round to, right? So 37 is going to round to 40. 17 is going to round to 20. Now those are much easier numbers to work with, so now I can get an estimate, all right? And this is what's called front-end multiplication. When I estimate in multiplication, I only have to multiply the front two numbers. That's why it's called front-end multiplication. So 4 times 2. 4 times 2 equals 8, and then I have 2 zeros, so I add 2 zeros to the end. And that's how we do it. That's how we estimate. Let's say I have 4,672 times 3. Well, there's nothing I can do to estimate for the 3, right? So this one, I'm going to round to the nearest thousand. That 6 tells the 4 to go up. So I have 5,000 times 3. Again, my front end multiplication, 5 times 3 equals 15. I have 1, 2, 3 zeros in the problem. So I have to add 1, 2, 3 zeros to the end. So my estimate would be 15,000. That means that my answer is going to be close to 15,000. It might be bigger than that, it might be smaller than that, but it's going to be close, or it should be. All right, and the reason why I say it should be, I'm going to use this bottom problem as an example. Okay, so the estimate can help me to check my work. So look at it here. Now I'm going to multiply 4,672 times 3. All right. For this particular example, I'm just going to go ahead and do what's called the standard algorithm or the traditional method of multiplication. All right. So I'm going to do 3 times 2 and multiply this bottom number times everything up top. 3 times 2 equals 6. 3 times 7 equals 21. I write my 1 and I regroup my 2, and I always circle it when I do this for multiplication, and I put the little plus sign next to it to remind myself that I have to add it in at the end. 3 times 6 equals 18, plus 2 more is 20. So I write my 0, regroup my 2. 3 times 4 equals 12, plus 2 more is 14. All right, so 14,016 is pretty close to 15,000. So I can judge that my answer is reasonable based on my estimate. If I had, let's say, maybe forgotten about the regrouping and made a mistake there, and let's say I'd forgotten to add in this plus 2 here, and I had gotten, okay, 4 times 3 equals 12. Well, 12,000 is pretty far away from 15,000, so then I could say, ooh, maybe I made a mistake someplace, and then realize, oops, I forgot my regrouping, I forgot to add that in. So that's where your estimation can come in handy. All right, so now let's move on to different multiplication strategies. Now, this is where I know a lot of learning coaches start to feel a little flustered because there are lots of multiplication strategies that we didn't learn when we were going through school. The reason for these strategies is it really helps to give the why behind the steps. Why are we doing certain things? And it also really helps to develop number sense because we're looking at what the value of each digit of the number is, and we're using that to help us multiply. I will tell you from a teacher's perspective that I have seen these strategies really help students who are struggling in math. I've really seen students latch onto these strategies and really grow in their understanding and their learning in math and in their confidence in math. So I want you to approach these strategies with an open mind because they are really valuable strategies. Now, that being said, this does not mean that to solve every problem your student has to do every strategy. This gives options and allows your student to figure out, oh, this one makes sense to me. This strategy does not make sense to me. I'm going to do this strategy because this makes sense to me. The end result is that they know how to solve a multiplication problem, no matter what strategy they're using. So if they choose to use partial products or if they choose to use the area model, great. If they think that the traditional method of multiplication is the easiest and that's what they understand the best, Great. The whole idea behind this, again, is understanding number sense. So if they're doing the traditional method of multiplication, as long as they understand the number sense, then they're good. Okay, so I just kind of wanted to preface this with that information. So I'm going to start with a 3-digit number times a 1-digit number. All right, let's look at 367 times 4. All right, now what the partial products method and the area model both do is they look at the value of each digit. So when I'm multiplying this 4 times 7, the 4 times the 6, and the 4 times the 3, well, 4 times 7 is really 4 times 7 because the 7 is in the ones place, so it's worth 7. But 4 times 6, it's actually 4 times 60. And 4 times 3 is actually 4 times 300. So what I'm doing is I'm just breaking down this by its values. 367 is the same thing as 300 plus 60 plus 7, right? That's what we learned when we did expanded form. So when I'm multiplying the 4 by this, I multiply the 4 times the 7, the 4 times the 60, and the 4 times the 300, and I add that all together. So here I would have 300 times 4 plus 60 times 4 plus 7 times 4. Again, it's just the value of each of the digits, okay? Now here's where our front end multiplication strategy comes into play. 4 times 3 is the same as 12, and I have 2 zeros, so I add 2 zeros. 6 times 4 is the same thing as 24, and I have 1 0. And then 7 times 4 is 28. And then the last step is to add all of these numbers together. To get my product. Now I will tell you guys that word product is really important. You have to know that the product is the answer to multiplication, because sometimes you might see a question that will say, find the product of 367 and 4. And if you do anything other than multiply, you're going to get the answer wrong, because product is only the answer to multiplication. All right, so I have 0 plus 0 plus 8 is 8. 4 plus 2 is 6. 2 plus 2 is 4, and 1 plus nothing is 1. So my product is 1,468. Okay, that's the partial products strategy. And it's the same thing when you have double digit times double digit numbers, but I'm not going to do that in this video. I'm going to save that one for the next video. Okay. Another way that you could do this would be drawing an area model. An area model is thinking, okay, well, when we find the area of something, we're talking about a rectangle, right? And we multiply the sides together to get the amount of space on the inside. So for the area model, you draw a rectangle. Sometimes you hear this referred to as the box method. That would be another way to think of it. And again, I'm looking at the values of each of these digits. So 364, it's important to write the right numbers down, guys. That is key. Writing the wrong numbers means you're going to get the wrong answer. 367 times 4, all right? And then I just take what's on top, what's on the side, multiply them together. 300 times 4, again, 4 times 3 is 12 with 2 zeros. 60 times 4, 6 times 4 is 24 with 1 0. And 4 times 7 is 28. And then again, I just add my partial products together to get my total. So it's the same exact thing I just added last time because I got the same partial products. Okay, the partial product model and the area model are very similar. Sometimes I prefer the area model over the partial product model just because it helps students to make sure that they get everything multiplied by all the right parts, especially when we move into double and triple digit times double digit numbers, okay? So 0 plus 0 plus 8 is 8. 4 plus 2 equals 6. 2 plus 2 equals 4. And 1 plus nothing is 1. Okay, now sometimes I see students do this, and this is fine too. Okay, I'm just kind of showing different things so you guys can see different methods. All right, so they write 367 times 4, And the students do this. They do 4 times 7 is 28. 4 times 60 is 240. And 4 times 300 is 1200. Again, making sure you line up the place values correctly. And again, you're still getting 1468. All of those ways you're doing this. Now, these strategies are really useful if your student has trouble with regrouping. And I do see a lot of students have trouble with regrouping. And if that's something that you're noticing as they're doing math, like, hey, they're not getting this regrouping thing, do it this way, because there's not any regrouping involved. Okay? This is a strategy where you don't have to regroup. So if your student is having trouble with regrouping, and that is a very common problem for fourth graders, that's why these strategies are really good. It's a good way to avoid that problem and avoid mistakes that can come when they forget to regroup or they regroup incorrectly. And again, as you move into the double digit times double digit multiplications, which is in the second multiplication unit, you will see that these strategies will even come into more play, because once we do double digit times double digit numbers, we start adding in that magic 0 and having to do all kinds of things that really can confuse some students. Now, it doesn't confuse every student. Some students love the traditional method of multiplication, and that's totally fine. Again, knowing the number sense behind the problems, knowing that 367 is 300 plus 60 plus 7 is the key behind these strategies. But they, again, are just helpful strategies that can help your student to achieve higher levels of success in math. So again, memorizing those multiplication facts, that's the first step, guys. Memorize those multiplication facts. If you don't have them memorized, check out the videos that I am posting in the toolkit, because they will help. I will post some other videos about this type of multiplication for you guys from other teachers that I know that have made really great videos. So that way, if you are watching this and you're still a little bit confused, they'll break them down by each individual strategy. So that way it's maybe a little bit easier to look at, because it's just partial products or just area model or just estimating or just traditional algorithm. Okay? Either way. Now, one thing I want to show you guys, last thing, and then we'll be done for this video. Okay, a very common way, and I said this already, but I'm going to show you, that you see multiplication problems written is, sorry, not that. Find the product of 4,203. Okay, find the product of 4,203. More often than not, here's what I see students do. They're like, find the product, that means find the answer. What's the easiest thing to find the answer to? Addition. I'm going to add 4,203 and I'm going to get 4,203. That's not the answer. Why? Because product is the answer to multiplication only. Okay? If it said find the sum, then you could add. If it said find the difference, then you subtract. If it says find the product, you have to multiply. And if you don't multiply, you're gonna have the wrong answer. Okay? If it says find the quotient, you have to divide. So because this says find the product, I know that the product is the answer to multiplication. So I have to multiply 4,200 times 3. And this time I'm going to do the traditional algorithm or the traditional method. 3 times 0 is 0. 3 times 0 is 0. 3 times 2 is 6. 3 times 4 is 12. The only correct answer for this problem is this right here, 12,600. Anything else is going to be wrong, because finding the product means I have to multiply. So math vocabulary is really important as well. If you guys have any questions, please ask. But also check out the other videos that we're posting, because they're also really great resources. And I know that you guys can do this. It just takes some time and takes some practice. All right, bye guys.